right, guys, here we go. We're going to work through this is practice problem number 5 for this week's homework. So let's practice problem number 5. And you had a couple problems earlier, previous in the assignment for this week, where you just were calculating an electrostatic force. Not difficult to do, right? F equals K Q1 Q2 over R squared, right? No big deal. In this situation, they're asking us, they've told us we've got these following charges. We've got a 1.2 microcoulomb charge that's positive, a 6.4 microcoulomb charge that's positive, and a 9.1 microcoulomb charge that's positive. And they're asking us, what is the instantaneous force on that 6.4 microcoulomb charge? Now, because of the fact that there's more than one charge involved, what do we need to do? Well, we need to calculate the effect that this charge, the 1.2 microcoulomb, has on the 6.4, or the charge between them. And we need to figure out the charge between the 9.1 and the 6.4, and then we're going to have two different forces, and we're going to need to add those forces together to get a final answer. Okay, so let's go ahead and work through that. So I'm going to start with the 1.2 microcoulomb and the 6.4 microcoulomb, and I'm going to call that force 1. Okay, so our equation for force, electrostatic force, F equals K Q1 Q2 over R squared. K is the constant, Q and the two Q's are the particular charges, and R is the radius between them. Okay, so here we go. So we got, and our K is 9.0 times 10 to the 9th newtons meters squared per coulomb squared. Right, that's all K. Our charges are, it is 6.4 times 10 to the negative third, right? Because it's a microcoulomb, to the negative third coulombs, times this one, 1.2 times 10 to the negative third coulombs. All of that over the distance squared, which is 1.5, okay, meters squared. So when I do all of that, I have two sig figs right here, so my initial force is going to be 3.1 times 10 to the 4th newtons. Now here's the part of this that's kind of important, is you have to figure out what direction this would be. So I'm thinking about this charge. If this charge, this positive charge, acts on this positive charge, what direction would it move this charge in? Hopefully it's clear to you that the force would be in this direction. Okay, so I'm going to go ahead and write that up here. F1 equals 3.1 times 10 to the 4th newtons. Okay, because this is positive, they repel, so this charge would be moved in that direction were it to come into contact with this charge. Okay, all right, let's go ahead and figure out our second force. And to do that, you got to look at the other same exact equation, different numbers. F2, 9.0 times 10 to the 9th newtons meters squared per coulomb squared, times my charges, again, same charge, 6.4 times 10 to the negative third coulombs. I'm just changing this to coulombs from microcoulombs. 9.1, millicoulombs. I say micro before? Millicoulombs. 9.1 is my other charge times 10 to the negative third coulombs. Now, the whole thing over 2.0 squared. And when I do that, again, I've got two significant figures, and so my answer is going to be 1.3 times 10 to the 5th newtons. Okay, again, positive charge, which direction is that charge going to move? How is it going to, in which direction does this charge impact that one? Well, it would be obviously in that direction because they're both positive. Okay, so that means this F2, I can write it with that one, is 1.3 times 10 to the 5th newtons. Okay, and now it's simply a matter of adding up those two charges. Okay, so what do we have to do that? I'm going to show you, we can't just add them because we've got powers, right? So I'm going to go ahead and write, I'm going to call, just like always, I'm going to call this positive and this negative, this direction negative. So what have I got? I've got basically negative, this here is negative 130,000. That's what this is. And this 3.1 times 10 to the 4th is a positive 31,000. Okay? So when I subtract or add those two, add this negative and this positive together, I get negative 99,000 newtons. But again, we are adding and subtracting, so I have to look at precision. What that means is I only have precision to, right, if I'm looking here at the original equation, I only have precision to 10 thousandths. So what I have to report as my final answer is negative 1.0 times 10 to the 5th newtons. Okay, hopefully that makes sense. There's a part B. I'm not going to do it on this video. I may make another video, but I just wanted you to see how that works. So let me know if you have questions, and there you go.